Okay, good morning class. So today we'll discuss a new topic, power of lens. Now, as the question says, define power of lens, give its SI unit, express power of lens in terms of refractive index and radii of curvature. So first we will answer our first question. Define power of lens. The power of lens can be defined as the tangent of angle by which it converges or diverges a beam of light falling at a unit distance from the optical center O. This means the power of lens means the tangent of this angle by which it converges. Clear? By which it converges. See, this is one tangent, this is another tangent, this is another tangent. Clear? The tangent of the angle by which it converges. This beam is moving parallel, later it moves towards the principal axis, so it is getting converge. Clear? It converges or diverges. Suppose this is your beam of light, it moves away from the straight line, that is your diverges. Converges or diverges a beam of light falling at a unit distance from the optical center O. Okay, fine. So what does this definition implies? This definition implies that power of lens is the measure of degree of convergence of divergence. That means how much your rays converges or it diverges. Clear? So we will just take an example of the convergence. That means how much your this lens can converge this rays. It can converge up till here, it can converge up till here, it can converge up till here. So how much it can converge, that measure is your power of lens. To understand it properly, what you can do is consider this two kind of lens. In the first case we have a red convex lens. In the second case we have a green convex lens. The red convex lens has a focal length f. It has a focal length f, whereas your green convex lens has a focal length this f. Is it clear? Focal length means what? When a beam of light moves parallel to the principal axis, after diffraction bends towards the normal, or it bends in this direction, the distance from the optical center to the point where they intersect is known as your focal length. So in this case you can see two different kind of focal length for two different kind of lens. One is your red lens, one is your green lens. Fine. Now tell me which focal length will be smaller. Will the focal length for your red lens is smaller or your focal length of the green lens is smaller? So which focal length is smaller? For the green lens. Okay, so what do you understand by this one? We have a convex lens, but in this case the beams are converging at this point, whereas for the green lens the beam is converging at this point. Can you see the difference of the distance? And why is this difference coming? This difference is coming because of the type of the lens you are using, isn't it? So what do you understand from this? We understand that your red lens has a bigger focal length. If it has a bigger focal length, that means it converges at a very big distance. If it converges at a very big distance, that means the power of the red lens is small, because power of the lens means how much it converges, whereas for your green lens it has a short focal length. Your green lens has a short focal length. If focal length is small, then what happens? Its convergence is also high. It can converge greater number of lines to a shorter distance. Clear? If it can converge into a shorter distance, that means its convergence power is high, which means your power is high. So what do you understand from these two cases? If F is big, P is small. P power is small or your convergence is small. If F is small for your green lens, that means your P is big. That means your convergence is big. That means it can converge it at a shorter distance. Is it clear? So what do you understand? The shorter the focal length, the higher will be the power. The higher the power means it can converge it at a shorter distance. It can converge it at a shorter distance because this convergence requires more power. Whereas if the focal length is big, your power is small. If the focal length is big, your power is small, means the convergence is small. That means instead of converging at this point, it is converging here. Why? Because the power of this lens is small. Is it clear? Fine. Now, to understand the tangent of the convergence or divergence, what we have to do? We have to consider this diagram. So figure shows a beam of light incident at a distance h from the optical center O of a convex lens of focal length f. Figure shows a beam of parallel or your incident light at a distance h from the optical center O of the convex lens of focal length f. It converges by an angle delta. What does this mean? This light is supposed to move in this straight line, but is it moving in a straight line? No. It bends towards your principal axis. It bends towards your principal axis. So can you see there is a bending? Can you see there is a bending? This bending gives rise to your angle delta. So it converges the beam by the angle delta. Is it clear? Fine. Now we know from our basics, whatever we have studied in our class 10, if there are two parallel lines, if we have a two parallel line and there is a transverse, if we have a two parallel lines and there is a transverse, or I can say if you have a two parallel line, okay, if you have a two parallel line, this angle will be equals to this angle. Why? Corresponding angles. If these two lines are parallel and there is a transverse, then this angle will be equals to this angle. This you have already done in your geometry of class 10. Clear? We can use the same concept here. These two lines are parallel. There is a transverse moving in this direction. So this angle should be equals to this angle. Why? corresponding angles. So this is delta, then this angle will also be delta. Any confusion with this one? Next, we know from our trigonometry. Again, this trigonometry concept has already done in your class 10 as well as your class 11. Okay, suppose this is your right angular triangle. This is the altitude, or let us say height. This is the base. This is my hypotenuse. Okay, this is my hypotenuse. So let us use a different symbol for this one, P. So this is my height, altitude, or your perpendicular, P. This is my base, B. This is my hypotenuse, H. Clear? Now suppose this angle is delta. This angle is my delta. Then tan of delta means your opposite side. Which is your opposite side? Perpendicular, divided by your adjacent side. Which is your adjacent side? Your base. Similarly here, this is your delta and this is a right angular triangle. Then we can use your trigonometry. So tan delta equals to your opposite side. Which is your opposite side? H, which is your height. Which is your adjacent side? Adjacent side is your F, which is small f. Clear? So next, let us consider this distance to be unit distance. Unit distance means what? This distance h to be equals to 1. So for my h equals to 1, this h becomes 1. So what do I have? 1 by f equals to tan delta. Fine. So this is my tan delta. The ratio of this side and this side is my tan delta. So the power of the lens is defined as the tangent. Tangent of the angle means tan delta. Tangent of the angle by which it converges or diverges a beam of light falling at a unit distance from the optical center O. This tan delta is known as my power of lens. Is it clear? So tan delta equals to 1 by f. And what do you mean by tan delta? Tan delta is my power. So P equals to 1 by f. So this is my formula. Power of lens equals to 1 by f. You should put it in a red box. Now, on the base of this formula, I can also write my definition of power of lens as power of lens may also be defined as the reciprocal of focal length. So P equals to 1 by f. Clear? So in your exams, your board exams or your class unit test, this definition is quite simple to understand and remember. So whenever the examiner asks you what do you mean by power of lens or define power of lens, what you can do is you can write down this statement. Is it clear? Okay. Coming to the next part of the question. Give its SI unit. Now we have to define its SI unit. The SI unit of power is diopter, which is denoted by capital D. Clear? Fine. Now we know power of lens equals to 1 by f. If my focal length is 1 meter, then what happens to the power of lens? Power of lens can be written as 1 by m. This m is the SI unit, which means your meter. I can take it to the numerator. So what will become? 1 meter inverse. Clear? 1 meter inverse, which is my 1 diopter. So 1 diopter means how much? 1 meter inverse. Is it clear? Fine. Now take a note. the focal length for a converging lens. That means your small f is positive. Your converging lens. Converging lens means my convex lens. This is my convex lens. If you have a light moving parallel to the principal axis after refraction, it converges to the point F. And the distance from here to this point is known as my focal length. Clear? Now we are measuring the focal length from the center, optical center to F, which is measured in which direction? From your left to right. If it is measured in left to right direction, your F will be positive or negative? Your F will be positive. So focal length F is positive. If focal length F is positive, we know power equals to 1 by F. If F is positive, that means whole term is positive. If whole term is positive, means my power is also positive. Therefore, power of the converging lens is also positive. Is it clear? Next, the focal length for diverging lens, that means your small f is negative. Your diverging lens means your concave lens. Okay, now in case of concave lens, what happens? You have a light incident from left to right direction. Light incident from left to right direction, and they are moving parallel to the principal axis. Now after refraction from this concave lens, they tend to move away from the principal axis. In such a manner that they appears to be diverging from a particular point. This point is my capital F, principal focus. So in this case, my focal length will be measured from the center of the concave lens to your capital F. And it is measured in which direction? From right to left. If it is measured in the right to left direction, which is opposite to your incident direction, so what happens? My F will be positive or negative? It will be negative. So my focal length is negative. Clear? If F is negative, then power of the diverging lens, we know P equals to 1 by F. If F is negative, what happens? This whole term is also negative. If this whole term is negative, what happens to the power of lens? This also becomes negative. Is it clear? So the power of converging lens is always positive. The power of diverging lens is always negative. Any confusion with this one? Now we know from your lens maker formula, 1 by f equals to mu2 minus mu1 by mu1, 1 by r1 minus 1 by r2. Or we can also write 1 by f equals to mu minus 1, 1 by r1 minus 1 by r2. This is my lens maker formula. So do you notice 1 by f? And what is 1 by f? 1 by f means my power. So can I write my power P equals to 1 by f equals to mu minus 1, 1 by r1 minus 1 by r2? Yes. Therefore, this is your answer of your final question. Express power of lens in terms of refractive index and radii of curvature. So by using the lens maker formula, the power of lens can be expressed in terms of refractive index mu and the radii of curvature r1 and r2. So P equals to 1 by f, which in turn equals to mu minus 1, 1 by r1 minus 1 by r2. So if you have any confusion, you can ask. Okay, so that's it for today's class. Thank you.